So myself, Sujisha, working as Assistant Manager in Bimlabs Engineering Services Pvt.Ltd. So everyone might be familiar of building information modeling. So I'll just start up with that. So building information modeling is an intelligent 3D model-based process that give AEC professionals the insight and tools to more efficiently plan, design, construct, and manage buildings and infrastructure. So you can see the Bim cycle. So in this, we are today discussing only about the structural BIM. That means a small portion of this life cycle of this BIM cycle. So what is structural BIM? Structural BIM processes help structural engineers, detailers, and fabricators improve structural documentation, minimize errors, and streamline collaboration across teams to accelerate fabrication. So what are the objectives of structural BIM? Structural BIM enhances structural quality, minimizes error, improves collaboration, connects design to detailing. I request every one of you to kindly mute your mics, please. So let us now discuss about the workflow of structural BIM. First of all, we start with the modeling, analysis, then comes analysis and design, detailing and fabrication, scheduling, documentation, and visualization. This is the workflow of structural BIM. So modeling, we can link up different files to Revit structure. Like if you're having a Revit architectural model, you can link up to this Revit structure. Or if you're having an AutoCAD file, you can just bring up that file to the Revit structure and you can place the components. So for modeling, Revit structures is used for concrete structures. And for steel structures, we can use Revit structure as well as we have an advanced steel software also. Why? Because for steel, general arrangement drawings and different drawings have to be made. So for preparing all those drawings, advanced steel is a better. So what we do is we model everything in Revit structure and we take it to advanced steel for creating the drawings. But when you consider the concrete structures, you can do everything in the Revit structure itself. So as I said, before starting, everyone might be knowing, maybe some of you might be using the Revit software. So in this, these are the different templates available. So when you work with the architecture model, you take default metric option or template. But while working with the structural BIM, you have to take the template structural analysis default metric. So that template is used. So if you're having this kind of architectural model, you can just take up this architectural model to the structural model so that you'll be having the reference. Definitely when you work in AutoCAD only, then also you should have an architecture model in order to create different layouts. So in the same way, if you have an architectural model, you can just take it to structural model to create different layouts and all. So how you can link up is in this way. You can just link up, you can just go to insert tab and you can link Revit files. So already in your architectural model, definitely you all know if you create an architectural model in Revit, it will be a 3D model and some columns might already be available and slabs or floors will also be available. But when you come to structure, that slab, that architectural slab should be replaced by concrete slab. And in the same way, architectural column should be replaced by structural column. So there we should not have two components like structural component as well as architectural component. So you can just copy everything what you want and use it. And in the same way, levels also. In architecture, you might be having more levels. Already levels will be there. If you want, you can just extract the levels what you want to use in the Revit structure and you can use it. No need to model it, no need to create the levels again. So in this way, you can see in architecture, I told you, you'll be having so many levels, but when you come to the structure, you might be requiring only less levels. So which levels you want, you can just copy it and take it to a structural template. So this dialog box, if you see the bottom one there, if already columns, architectural columns are available, then you can change it to the structural columns. In the same way, if you are having a floor, you can just convert it to structural floor and you can use that same floor. Floor means slab, same slab in structures. So if you see this tab, you can see there are different families already available like slab, beams, columns, walls and all. So walls mean you can create shear wall and retaining wall. Isolated footing is there. You can use that isolated footing directly, or otherwise you can create different types of footings. Like if you want to create trapezoidal footing, you can create it as a family and you can save it, or otherwise you can just model it in that project itself. So all these are by default available. So you can just take any one of it, and if you want to change the properties, you can just change it. If you see the type property dialog box, then you can see you can just change the properties and then you can use it. I'll be showing all these in the Revit structure. So then you can place the beams and columns. You have different options. You can model individually, or otherwise if you have created the grids, then you can just place it on the grids. If you can, if the beams or columns are available on the grids itself, then you can directly use on grids option and you can place it. So in the same way, you can use the slab also. Then we have to, after modeling, so in this way I think we can model everything. So after that you have to analyze and design the structure. For analyzing and designing, we have different softwares. Everyone will be familiar about StratPro, ETABS, SAP and all. We have Strap, Struts, so many softwares are there, but everyone will be familiar of StatPro and ETABS. So you have one more structural analysis software called Robot Structural Analysis. It is a product of Autodesk. So to that software also you can take this Revit structure model and you can analyze and design it, or otherwise you can take it to StatPro or ETABS. Different plugins are available in order to take our model to StatPro and ETABS and rest of the softwares also. So before, so we have created the model. Before taking it to the to analyze and design, we can create or we can provide the boundary conditions, loads, load cases, and load combinations in the Revit structure file itself. So this is the thing where you can see different boundary conditions option is there, loads option is there, load cases and load combinations options are available in Analyze tab. So in the Revit structure itself, we can apply everything, and finally you can take it to any of the analytical software just to analyze and design it. So after taking it to any analytical software, no need to apply the supports, loading conditions and everything. You can give everything in the Revit structure. So when support conditions, boundary conditions are taken into consideration, you have three different support conditions. Like you can apply in three different manners, that is point, line and area boundary conditions. If you see onto the left side, I have just clicked on point option. In that point, in state you have fixed option. So there different options are available. Fixed, pinned, roller supports are available, or otherwise user defined is also available. If you want to create your own type of supports, you can just create it. So when you come to the next one, loads. So there are different loads like point load, line load, area load, hosted point load, hosted line load, and hosted area load. So when I just clicked on point load, on the left side, if you see, you are having load case. Already dead load is available in the software itself. I have not created it. By default, it is there. Now, if you want to apply point load in the vertical, you can provide the value in F set in the negative. So if you have the moment in XY directions, you can place it. If you have the forces in horizontal direction, you can give the value. You can just create your own type of loadings and you can just provide it. So when you come to load cases, you're having different load cases. Like dead, according to Indian code, if you consider, you have dead load, live load, wind load, and seismic loads, which are already available in the Revit structure. So when you see the next one, load combination tab is also available. In this itself, you can create the combinations and you can just take it to structural analysis software. So how to export it to ETABS? So you are having a plugin called export to ETABS. So by that you can just export that ETABS structural model to the ETABS by using this export to ETAB. And another plugin is also there, CSI link. With that CSI link, you can just export the model with the boundary conditions and loadings to ETABS. I'll show you that CSI link once I open my Revit interface. So all these plugins are available in Autodesk App Store. You can just most of them are freely available. You can just use it. So after exporting to ETABS, you can just open in ETABS file as ETABS.e2k text file or otherwise IFC file. You can just open the file and you can just analyze and model. So next comes the robo structure. This plugin also available in Autodesk App Store. In that you can just export the model from Revit structures to the robo structure file. You can analyze and design in robo structure. It is also similar to STAD and ETABS itself. So if you want to export it to STAD Pro, then you have an option called ISM standards. Then you can export it to STAD Pro also. So after analyzing and designing, you can detail it. And you can create a detailing and fabrication drawings. So detailing and fabrication, as I explained it before, we can do it in different softwares. Revit structure, advanced steel, what we use for concrete and steel. But traditionally AutoCAD, ProSteel and Tekla is also used. So instead of that, we can just use Revit structure for concrete. And when you consider the steel one, you can use advanced steel as well as Revit structure. So when you come to structural detailing, we are having different types of detailing, like area, path, fabric area and all. So you can use those methods and you can directly place the components, rebar components. So if you see this, already different rebar shapes are available. You can use that shape and you need to just place it. And if you know the spacing, you can just provide this at the top. I'll be showing you this clearly. Before that, I just wanted to explain it. So you can give the tie hook and all. In the properties of that, you can provide everything. And if you want for the presentation purpose or all, you might be requiring a 3D model. So you can easily take up the 3D model also. So next comes the estimation and scheduling. There, the first one we do feel difficult in traditional concept is taking the bar bending schedule. So once we take some time to model it, after modeling it, it will be easy for us to take the bar bending schedule. Within clicks, you'll be getting the bar bending schedule. When you consider manually, it takes lot of time to get the bar bending schedule and everything. But in this software, we just get it within clicks. Then comes the documentation. As we have already modeled, we have a tags option. So we can just tag it so that it will directly give the naming and all. So no need to create it. No need to type it and use it. You can just create tags some tags are already available, or otherwise you can create some tags and you can save it so that you can use it regularly. So no need to type it again and again. You can just create a family of that tag and you can use it. Then comes your steel structure modeling. Till now we were discussing mostly about the concrete structures. So in concrete structures, we have consider in structure tab, you will have beam, column, wall and everything, and rebar is also available in the structure tab itself. So in the same way, you have steel tab. In steel tab, we have different types of connections and different type of fabrication elements like plate, bolts, welds and everything is there. So you can directly use it. So this is a type of modeling in Revit structure in steel. So all these components are already available. You can just take it and model it. So these are the some junctions what you can create. So these are more than enough for steel structures. So next case comes the fabrication elements. As I already told you, we have plate, bolts and welded connections, which we can create your own type and you can just place it. So these are some steel connections: beam end to end, apex haunch, column beam, seat angle, gusset plate at one diagonal. These different connections are already available in Revit structure. So this is the dialog box what I have taken from Revit structures. So you can use it, load it and you can use it. If you want to edit it, you can just double click it so that you can edit the properties of that and you can create your own type and you can use it. So custom farm connections, you can create your own type of connections what you want and you can use it. Then comes the documentation. So if everyone is familiar with Revit architecture, then you can easily understand this. So this is a custom connection tag. You can create the custom connection tag also. Then if you want to export that steel model to Revit, steel model to advanced steel, then this is the plugin, advanced steel extension. So this is the plugin which is from Autodesk App Store. You can just download it and you can export it. So advanced steel is also like AutoCAD. It is also having an AutoCAD interface, so you can easily use it. Okay, so this is all about the software. Now I'll show you the software and explain you. Okay, so this is a structural template what I have opened and I have created only 3 levels. I'll show you that. So only 3 levels are there: pedestal, plinth level and roof. I'm not taking a big structure to explain you. I'll take a small simple structure so that everyone can understand it clearly. Okay, if you see it at the bottom, I have a pedestal. At 0 level I have a plinth level and at 300 level I have roof. Okay, if you don't have an architectural model also, you can directly use it. Use the Revit structural template and you can model the structural elements. Okay, so now I have placed some grids also so that it will be easy for me to place the components. So now if you come to the structure tab, so the first one was architectural tab. All the architectural components are available. If you come to the structural tab, you have different structural components here, so you can use those. So let me first model a column. So I'll take the column. So in this, different options are available. Concrete columns, I have prepared 2 columns, like column and pedestal, so that I can use it for modeling. So I'll just take a column and my column ranges from plinth to, it's not depth, I have a height of that column. it is still roof. So I can use the option add grids options. I can just place it. So columns are placed. Now let me take up pedestal. There the pedestal has to go below the plinth level, so I'll change it to depth, and it is plinth. Again, I'll just use the option at grids. Just finish. Okay, now I have to model the plinth beam. For that also, in structure tab, I have beam option. If you click the property dialog box, you have different types of concrete beams are available. You can just change the section and you can use it. Okay, so for that, I have created beam and plinth beam. Two beams already available. I have created it. So I'll just take up the plinth beam option and I'll just model it. Actually, it's modeled on the top. So what I'll do is I'll just select it and I'll change my reference level to plinth level. Okay, you can just model it like this. So if you see the 3D view, now plinth beam is modeled at the plinth level itself. Now, if you come to the roof level, I need to model the beam at the roof level. So I'll just change from my property, I'll change it to beam. And I'll just model it here. Okay, so in this way you can just model it by preparing it. And now if you want to create a slab on the top, you can just create in the same way. In the structure you are having floors. If you click on this floor, you have floor structure option. You can just take that floor structure, go to edit type. In this way I have created the beams and columns. So I'll just show you this. You can just duplicate it and you can create a slab. Okay, then I'll just change the thickness. I'll just edit it and I'll change it to 12 centimeter. If you want, you can give the material and everything also here, so that for while taking the estimation and all, it will be clear. So now I'll just draw it. So now my model is ready. If you come here and make it realistic, then you can see it. See, all the structural components are ready. Now, so after creating this, you have to apply the loadings and all. So for that, you have to create the analytical levels. So by default, for the 2 levels, you'll be getting the analytical level. Otherwise, you have to create the analytical levels for all those. So if you come here in the 3D view, you have different analytical 3D view. If you just click on this, you can see this. This is the analytical model. So now, in order to apply the loads and all, or if you want to apply the supports, let us start with the supports. So for that, in Analyze tab, you have an Analyze tab here. If you come here, you have boundary condition option. You can just use it, and at the point I want to apply the condition, so I'll take the point option itself. And if you come here to the state, you're having different supports: fixed, pinned, roller, and user defined. You can create your own type. So if it is a fixed one, I'll just use that fixed one and I'll just place it like this. So the supports are already applied to the structure. Now if you want to apply the loading and all, like wall load and slab load and all, it will be easy when if you take it as a floor plan. So in the plinth level analytical, I'll just go to the plinth level analytical, then I will apply the loads to this one. So if I want to apply a wall load, then you can just go to loads option. In loads, definitely a wall load will be a line load. So you can just select it, line option, and you can give the value of Fz. So Z is my vertical direction. So if you see here, if I click here, you have different load cases available. So I want to apply that wall load to the dead load itself. So I'll take this dead load itself and I'll change my Fz value to 12. I'll take the wall load as 12 kilonewton per meter, and I just need to model it like this. So my 12 kilonewton is already applied. If you come to the analytical model, you can see this 12 kilonewton per meter is applied. In the same way, you can easily apply all the uniformly distributed loads. And if you want to apply the slab load, let me come to the roof level. At the roof level only, I have the slabs. This is the roof level analytical view. Now, if you want to apply the load to this one, then you can go to roof. In this roof, I am having sorry, not roof, load. In that load, I'm having area load option. You can just click it, and to the dead load, I'll apply 1 kilonewton per meter square load as a floor finish. So I'll use the same one, and I'll take a rectangle option to show the area. Okay, then I'll just finish it. So when you come to the 3D view, you can see it. When you come to the analytical view also, you can see it. So that area load is transferred to the beams. That's all. Okay. So in the roof level itself, if you want to apply the UDL, then you can do the same. Or otherwise, you can do the same. Like if you come to the loads, take up the line load. So let me apply a load of parapet load of some 2 kilonewton per meter. I'll take it as 2. It is also in the dead load case itself. So I'll just model it now. Okay, so that is also applied. And if you want to again apply a live load of in residential and all, you'll have a live load of 2 at the floor levels and 1.5 at the roof levels. So I'll apply a 1.5 kilonewton per meter square area load on the live load. In the live load case, for that I'll take the area load and I'll change the load case to live load, and here I'll change my Fz value to 1.5. Then I'll take this rectangle option and I'll just model it. So in this way, I'm just showing the area where the load has to be applied. Then just I'll finish it. So all the loads are applied. If you see this analytical model, you can just clearly understand 3 loads are applied onto these beams. Why? Because the area load is already converted and applied onto the beams. It will be shown in this way only in the Revit, but it is actually the area load itself. So now if you want to apply the combinations, then you can use this option. In load combinations, if you come to load combination and click on add option, so you can give the name here. So let me create a combination of 1.5 dead load plus live load. So I have created it. Now in order to add the formula, what I'll do, I have to create the formula here. So I'll just click on add. So dead load is already there. I'll change my factor from 1 to 1.5 and again click on add. So that I'll change the factor again 1.5 and then I'll change the case to live load 1. So you can see the formula here. See, formula is created 1.5 dead load plus live load. So this is a type is combination. If you have different combinations, then you can create. If you come here, you can see you have envelope option also. So if you're having more combinations, then you can create an envelope by using all the combinations. So this is how you can create the combination. Now you can export the file to export to etabs. I'm having my etabs option only in this one, etabs. Or if ISM file is there, ISM plugin is there, then you can export to that. And if you see, CSI link option is also there. Through using this CSI link option, you can just export loads, combinations, and supports everything to etabs. And I'm having RoboStructure analysis also. You can just export it to RoboStructures and you can analyze it. Since the Indians are not familiar about RoboStructure, I'm not going to that portion. So in this way, you can just model and apply the loadings and combinations. Now let us, after we'll send this file to any analytical softwares, then we'll analyze it and design it. After designing it, what we'll do is we will start our detailing. So for that, let me start with beam. So I'll go to roof level. So now I want to detail this beam. So while starting the detailing, first of all, the main thing you have to do is you have to create the cover. For that, the structure itself, I have an option here, cover. You can create the cover. You can just click on it. By default, some covers are already available. If you want to create your own type also, you can do it. You can just click on here and add a type. Let me give it a name as rebar cover 20 mm. So here I'll change this value to 20. So I have created a 20 mm cover. In this way, you can create it. So now if I just click on this beam and you want to apply that cover to this beam, so the beam properties are available on the left screen. So if you want to change it, you can just come here, rebar cover top, bottom, and others. So if you want, you can just come here and change it to rebar cover 20 mm. So that cover is already applied to the beam. Now I have to start modeling by longitudinal bars and stirrups. So for that, you have to start doing it by creating the section. So I'm creating a cross section and I'll just open that cross section. So this is my beam. Okay. So now what I'll do is I have to place the main bars and stirrup. So I'll go to structure, I'll go to a rebar option. Okay. So see, these are the different rebar shapes already available. Okay, different rebar shapes are there. See, you can use this one for the foundation. You're having the stirrup shape also. You can use it directly. Okay, so these are the different bars shapes available. So I'll take for longitudinal bars, I'll take rebar shape, a straight rebar shape. Now I'll just see, you have got a longitudinal rebar. So if you want to change the diameter and all, you can just come here. I'll use 16 mm dia. So I'm just clicking on that. So already rebar sizes are also available. If no, you can just create it also, edit it and create it. So this green color shows the green dotted line shows the cover. So wherever you want to place it, you can just place it. So I have provided 4 bars, main bars of 16 mm. And now I'll provide the stirrup. For that, I'll go to again rebar and come to the bottom, and I'll select that rebar shape. I'll use the shape, and here I don't have 8 mm, so I'll use 8 mm bar size for stirrups. So I'll take this 10 mm and I'll just edit it. Go to edit, duplicate. I'll make it as okay. I'll change my bar dia to 8 mm. Okay. Then I'll just change the orientation. Stirrup is there. If you just rotate it, the hook will be changed. So if you want to place in this direction, I'll just click here. So a rebar is placed. Now, if you select this rebar, so only single rebar is modeled, a single stirrup is modeled. So you don't need a single stirrup. You should have a series of stirrups. So for that, you can just change the layout from single to maximum spacing. If you know the maximum spacing, you can give maximum spacing. If you have the fixed number, you can just give the fixed number. So for stirrups, generally we go for maximum spacing. So if you want to change the spacing to 150 mm, just you have to do this one. So when you come to the 3D view, so if I just move on here, you can see that arrangement. So if you want to clearly see that one in this view, you can just select it out like this and filter it and take only the structural rebar, apply, okay. And I'll change the visibility state. Now if you see, you can see it as a dotted line. Now I'll change it to fine. Then you can see it as you can see the realistic view. This is how you can model the stirrup in, or you can model the rebars in wheels. So in the similar way, you can model it in the columns also. So if you want to decrease the transparency of the concrete, then you can see it a bit clearly. So I'll just increase the transparency, so we can clearly see this. You can change the parameters. See, if you select this stirrups, all the parameters are there, hook and everything is there. All the parameters or properties can be changed here. Now if you want to model any I'll just place a foundation and then I'll model the rebar. So for that, I'll go to the pedestal level and I'll use this option, isolated. So I'll use the same one, say with the same dimension, I'll use it. So I want to place it here. If you see, if you press on space, you can just rotate it also. So in AutoCAD, what you need to do is you have to place it, rotate it, and use it. In this, you can just use space option. So see, already foundation is there. So now I'll take up the pedestal level. I'll just reinforce this foundation and show you. I'll just take a section like this and I'll go to that view. So we have to just come down in order to see that one. Okay, so you can just select it and change the cover. Since I have not created any 40 mm cover and all, I'll just give the same 20 mm for the time being. Now, if you want to reinforce this one in the same way, you can go to rebar option. So you can select the shape, whichever you want. So I'll take this one. Okay, then I'll change my size to 16 mm. So I have just placed one. Now I need to increase the number or change my layout from single to maximum spacing and increase my spacing. So I have just placed it to 150. Then again, I'll come to my pedestal option. I'll just create another section in this view so that I can place the bars in the other direction also. So I have just taken that one. Come down, you can see it. See, this is the other sectional view. Now again I'll come to structure, rebar. I'll take the same one, 18 itself. I'll just place it. Now I'll select this one, change from single to maximum spacing. Again, I'll use this 150 mm itself. So you can see this. Now you need to change the visibility of that one. So I'll just change it again and show you. So see, in this way you can do it. Okay, in this way you can create or you can rebar all other elements also, like beams, columns, slabs, plinth beam and all. And in this one you can see you don't have a trapezoidal footing kind of thing. So if you want, you can do it from in component. You're having model in place option. So in that you have structural foundation option. So using that foundation you can just create your own type and you can use it. Okay. So now let me show you how to take up the bar bending schedule. It will be easy for you to see that one. So in view I'm having schedule option. In that I am having schedule quantities. So I'll just take structural rebar. I want to take the quantities of structural rebar. Then I'll take A, B, C, bar, diameter, T, E, F, and type G. And we are just selecting the fields, whatever you want to use it. And you're having total bar length. Total bar length is there. Reinforcement volume is there. So I'll just rearrange it. Family and type at the top, bar dia again at the top. I'll tell what this ABC is: total bar length and rebar reinforcement, rebar volume. So this is the schedule. See, we have directly got the total bar length as well as the reinforcement volume. This ABCD indicates the bends. So wherever you want to bend the stirrup or the bar. Okay, so you might not be understanding what is A, where is A, where is B, where is C and all. So you can just add the images and all. So I'll show you that. Before that, reinforcement volume is there. Now if you want to calculate the weight also, you can do it in this one. That means extra calculated parameter can be added. For that, I'll just go to this edit option and I'll add this parameter like weight. So my discipline is not common, it is structural. I'll change. So if you go to weight, it is our mass. So I'll change my type from mass. Then I'll create the formula for that. If I click here, I have reinforcement volume into the density of mild steel is 7850. Okay. So if you come at the last, you have the reinforcement volume. And reinforcement volume and weight we are getting in kg. If you want, you can apply one more calculated parameter in order to convert it into tons. Okay, in this way you can do it. So in this fields itself, I'm having a shape parameter option, shape image option. So I have just added a shape image. Okay. So in this one, you cannot see that shape image. So we have a none option. So I'll just go back to any of this. Okay, I'll just go to the 3D view. So now, if you want to apply the image of this ABCD, where the particular to after which what length the bar should be bent. So I'll just do one thing is, I'll select this stirrup. I'll go to edit family. So see, in this one you can see this is E, D, C, B. So in some it might be A, B, C, D. In some it might be C, D, E, F and all. So already these are available in family of Revit structure. If you want, you can create your own type and you can name in this way. So if I want to add this image, I'll just snip this image now. And I'll add that image so that you can directly give that schedule to the site. Okay. File save as. I'll just save it in the desktop as demo. Okay. So I'll just add it to family type. I'll just come here, and here you are having shape image option that I can just select. Go to add option, and on the desktop I'm having demo PNG. So that image is added to that. Okay. Then I'll just load into project and override the existing version. Now, if you come to schedules here, what we have taken up before, here you have a demo.png option. When you convert or when you take this rebar to a rebar schedule to the sheets, then only you can see that image. So for that, I'll create a new sheet. I'm taking A1 size itself. Then I'll just place that rebar schedule. Then see, you can see that image. So now, if you want to, I'll just come to the section. Different sections are already available. So I'll come to section 1. Now, if you want to tag it in annotate, you have an option tag by category. You can just click on it and tag it 8 mm. And in the same way, if you click on it, you can use it. So you have 60 mm2 at the top, and you can reduce the size and all. If you just click on this one, you'll be having that name is what I have given is beam. So if you give it as beam 2 by 20 by 25, that size will also be there. And if you come to the section, so if you want to do the same one in this also, you can just do it. So you can just directly tag it. Foundation. So now if you want to bring out this section, so I'll just drag it wherever I want. I'll just drag it. Only this portion is required in my image or in my sheet. Then I can just go to, this is section 3. I'll just drag this section 3, the sheet. So you can see section 3 is there. So now if you want the plinth level, if you come to this level, if you want to just give the dimension, and you can just add this one also to the sheet. So for that, you can just go to the same sheet. I'll just take out the plinth level sheet. You can add it like this. You can decrease the scale and everything here, or increase the scale and all. So you now understand how easy it is to do the schedules and set the sheets and to create the text and all, tags and all. So it is very easy in Revit structure. So I'll just open and show you the steel structure also. So I'll just, I have modeled one steel structure. I'll just show you that one also. So this is a steel structure. So when you zoom in and see, you can see you can create this type of connections also. So in steel, you are having connections option. Okay. So different connections are already loaded in this one. You can use any of these connections. So these are the different connections, and at the top also you are having, see, these type of connections can be created. So this is how you can model it. If you see, this I section is there, I section is used as purlins and all. So it is easy because since the families are already available, you need to just change the dimensions in concrete. But whereas in steel, no need to change the dimensions also when you consider the frame sections. Why? Because according to the code itself, it is set in the family. So you can just pick up that one and you can just do it. So you can take the concrete quantities of beams, columns, and slabs and everything also, how much quantity is there, concrete quantity is there. You can just take that one also. So I forgot to show that one. So let me open that file again. Okay, now in this one, if you want to see the concrete quantity, then you can do it. And I'm having in material takeoff. I can just use the structural column. I'll take the material take of the column. Okay. I need the family and type count, and I'll take material volume. So you can get the material volume also. So which column is that? If you want to just check out, you can just click on this and you can go to 3D view and see that column. So this blue one is that column what I have selected. And you can do different things also. You can create your own stirrup type or own rebar type, and you can keep it so that you can use it anytime. And you can get the formwork area also. You can calculate it using this estimation, using the schedule itself. You can directly get this formwork area and all also. So this is a bit about structural BIM. If you're having any doubts, you can just unmute and ask, or otherwise you can put on the chat. Okay, first thing, yes, certificate will be provided. One questionnaire will be sent to every one of you. If you complete that questionnaire, then you can just get the certificates. Yeah, Sukrit Jain, you can use the BIM in MTech projects. You can freely download it from the Autodesk site. Student version is available. 3 years students version is available. So Sukrit, you can use it. Do we need to consider the loads and supports in Revit when it comes to the analysis and design part? We can assign it. Yes, definitely you can assign it in any of the structural analysis softwares. Assigning in Revit model and importing to ETABS for analysis would be difficult. From the structural designer's perspectives, what's your opinion? So the same way how you apply in the ETABS, in the same way you can apply in the Revit also. So I don't feel it as difficult. And you can apply it and you can directly take it to CSI link through CSI link option. So everything will be exported. So you can use that model. You can just check the model and you can just run the model and design it. It won't be difficult. Shock length of bars is 6 meters. That you have to individually draw it. You have an option in rebar. While creating the rebar, you have an option called sketch rebar. With that, you have to model it individually in order to get the total control of that length of the bar. Yeah, recorded session will be sent. You have to export this model with the loads and everything to the analysis software and see whether it is safe or not. You cannot analyze in Revit structure. You have to do it in any other softwares. I think it is 50% you have to get in order to get the certificates. Yeah, vanilla free educational version, free student version is available in Autodesk site. If you just create your ID, then you can just download it from Autodesk site. We cannot analyze, we cannot do, in Revit structure, we cannot do the analysis portion. Yeah, definitely you can import the data from ETABS to Revit also. So once if you're having an ETABS model, you can directly import into Revit structure and you can detail it, no problem. Some Mohammad Rian, some tutorials are already available in our YouTube channel, that is bimlabs.in. You can just check out that. And this recorded session will be also sent to you. Yeah, thank you, Riaz. Yeah, Praveen will definitely share that one. Yes, where can students get trained for this software? Yeah, I'll just tell you that one. My mom, can't we do analysis in Revit structure? In Revit structure, we don't have an option for analysis. That's why we cannot do it. Use this for my MTech thesis. Good, so great. You can use it for the MTech thesis. Can you please show us completed schedule of any of the work in Revit structure? Thank you, ma'am. Okay. So I want to add up some things to my presentation. Okay, and someone had some doubt. Can you please show us completed schedule of any of the work? Yadu Krishnan, we'll do one thing. Actually, I'm not having a file with me. We'll do one thing. We'll just take up our work and we'll do the schedule and we'll give that link. Then you can just check out. Is it clear, Yadu Krishnan? Yeah, Mohammad Rian, it is only for modeling. YouTube channel name is bimlabs.in. Thank you. Yeah. So I want to add up some more things. So let me first of all tell you a few lines about Bimlabs. So Bimlabs is situated in Kerala. So it is an authorized training and learning partners of Autodesk and member of Indian Green Building Council. So we train students and corporates in BIM, and we help to implement BIM in corporates and organizations. We do BIM projects outsourcing and BIM placement services. You can just note down the phone numbers, WhatsApp numbers, and mail IDs. If you have any queries also, you can just take up a call, otherwise mail it so that we can sort and help you out. So I want to add the two more things. So we are arranging a 5 days faculty development program. So in order to what we say, in order to develop the faculty's knowledge in BIM, we are just doing it for 5 days. From June 1st to June 5th, we are doing it on structural BIM itself. So the requested candidates can just contact on the numbers given below. So in this also basic architectural modeling will also be covered. Basic architectural modeling will be covered. Then we'll link that model to the structural model. Then we create different layouts, and we do the detailing of beam, column, slab, and foundation and staircase also. And we'll take up the schedule and estimation. This is the thing we'll be doing in the 5 days session. And someone of you asked, how do we get training? Actually, we are doing some trainings in structural BIM. Like we are doing 15 days training in structural, online training in structural BIM. So these are the topics what will be covered. That is, basic architectural modeling should also be known. It's not like you can directly start from beam, column and all. So you have to know the basic things of architecture also. So that portion is also included in this one. So it starts with basic structural modeling, creating building envelope, managing parametric families, linking projects and collaboration, structural views and modeling basics, columns and beam layout, slab and foundation layout, applying loads in Revit, structural families, columns and beam detailing, beam and slab detailing and documentation, structural stair modeling and detailing, schedule and estimation, steel modeling, steel detailing. So these are the contents we'll be discussing for 15 days, and you'll be getting the certification of Autodesk also for this course, structural BIM course. So the interested candidates can just use these numbers, can contact in these numbers for FDP or any BIM related queries. You can just contact in these numbers, or you can just mail it. If you are an MTech student, you can participate in the FDP. If you are not an MTech student, then you can join the course, 15 days course. Yes, we are providing e-certificate for this. Sukrit, can you just contact in this number so that you can know whether it is free or not? In Kerala, we have offices at Trivandrum, Calicut, Cochin. Mohammadrian BIM is nothing but it is a cycle. That means from the conceptual design of a building till the demolition of the building, there are different processes happening, like conceptually modeling it, detailing it, then detailed drawing is prepared, then that detailed drawing will be sent to the structural engineers as well as the MEP engineers. From that, an output will be there. So that output has to be checked, whether clashes are there or not, that has to be checked. Then it will be taken to the project management consultancies in order to know the time, and as well as how much time it will take for the construction, as well as the budget. So after completing the everything, so this is just a cycle. Revit is nothing but Revit is a tool in BIM for modeling. Simply what we can say, Revit is a tool in BIM for just modeling. So Revit, by using Revit, you can do most of the things in that cycle. So we generally use Revit. Certificate, Ramkumar, certificate link will be provided. Don't worry, after you get that questionnaire. Gopika, we are providing an e-certificate. You'll be getting it. MTech students can participate in the FDP. The rest has to undergo the structural BIM course. No prerequisite knowledge is needed for training in BIM. If you are an BTech or ITI or diploma candidate, then you can easily do that. If you are not related to this field also, you can develop it, no problem. Divyakant, which one are you talking about, the FDP? Yeah, sure, you can do it. No, you don't have a branch near New Delhi, but we are, since we are in lockdown, we are doing online sessions now. So, Krit, if you are interested, you can just join in online courses. We are having lot of BIM modeler opportunities as junior BIM modeler opportunities in the worldwide. If you just see on the LinkedIn, then you can see there are a lot of opportunities. Why? Because we are also placing our students before completing their course in Bimlabs. The students are getting placed in different BIM companies. So the vacancies are more, but the candidates are less for that, because after completing BTech and all, most of students will be going to site or any other site works or otherwise as site supervisors and all. So there are only less numbers who know about BIM and who are working in BIM, but the opportunities are heavy. If you just search in LinkedIn, you can just know it. Yeah, you can, Yadu we have a platform called Navisworks. In that, Revit architectural file, Revit structural file, as well as Revit MEP file can be added to that Navisworks platform, so that if you have any clashes, that means we may have clash between the column beam and some duct going on and all. So that clashes can be detected there, and easily that can be rectified. And after we run the tests, or we run the clash detection in Navisworks, then you can see a zero error model will be out for the construction. So there won't be any delay um, or any delay in time or increase in budget due to the clashes and all. There won't be anything if you work out with Navisworks. Yeah, Mohammed, yes, you'll be getting the feedback form. Praveen, thank you. Yeah, Badiga Shiva, yeah, we are definitely providing the training for MTech structural engineers, as well as we are placing them also. We'll do one thing along with the feedback, or otherwise along with the questionnaire. We'll share the placement list what we have placed also. In that, the first placement what we have done was from an MTech. It was an MTech graduate. She was working as assistant professor. Then she left the job and came to us, and she learned construction management BIM course, and we placed her in at a big MNC company. So we can definitely place MTech structural engineer students also. Yeah, Praveen, thank you. Ram Babu, thank you for this. Sukrit, till now we've not had any issues with the placement. We are not focusing on STAD Pro or ETABS. Definitely we do training in STAD Pro, ETABS, individual softwares also, but we are mainly focusing on ETABS. So, sorry, mainly focusing on BIM. So, from now the situation is like the students are not in a condition to complete the course. Before that, we could place all the students. So Sukrit, I'll definitely send you the placement list. You can just check out, and I think you can clear your doubts, or you can just contact in the numbers what is shown, or otherwise I'll share my mail ID and number also. Yes, this is my mail ID and number. You can just take it out, and you can just call me. Yadu Krishnan, for clash detection, Navisworks is the best one. Feedback link will be sent to your mail. Can you just contact in the numbers what I have shown before, Satyanathan, so that you can be knowing about the fees and all for the FDPs? Yeah, you can use bridge in Bim in bridges. Like you're having a platform called InfraWorks. In that, you can model the bridges and all also. Bridges, roads, culverts, drainages, everything can be modeled, Karthik. Actually, from next Saturday, you are having a free session on InfraWorks. If you can just get that link and you can attend the session, then you can clearly know that. Okay, Sukrit. We can help you out if you are interested in BIM.